We're going to tie in inverse functions shortly, but first I have a question for you.
What would you do for a Klondike bar? What would you do for a Klondike bar?
Interesting, right? I know. So let me ask you a question. What would you do if you had a triangle set up and you did not know the angles that were inside? Like, for example, you don't know this angle or this angle. You just know that it's a right triangle, and pretty much that's it. Maybe you have some side lengths, 2 specifically. But what would you do to get a hold of these angles? Well, you wouldn't throw your head into a fan. You wouldn't hop off of a moving car. You would take what they call inverse trig functions. So recall that if we were taking sine of angle A, this would be equal to the opposite over the hypotenuse. So this would be A over C. Cosine would be B over C. Tangent would be A over B. And so if we were going to get a hold of the angles themselves, for example, angle A, we would be taking a look at what they call a sine inverse. So we would take sine inverse of what that ratio was equal to, A over C. And if we were going for cosine, we would do the same thing, but we take cosine inverse of B over C. What do you think we would do to get a hold of angle A using another trig function? You should be saying use tangent inverse of A over B. Makes sense, right? This is what the ratio was equal to get that trig ratio. So if we use the inverse, this will kick us back the angle. Take a moment, try out this bit here for angle B. Well, you know that if you're standing at angle B up here, your opposite is B. You would then take that over C. Sorry, I'm getting this ready for the next example. You would do A over C for cosine of angle B. And then finally B over A for that. So if you wanted to solve for angle B, we have several ways to do that. We could take hold of sine inverse B over C, cosine inverse A over C, or tangent inverse of B over A. So we have several ways to get a hold of the same angle. So maybe pause real quick, take note of this, and then we'll move forward. So if we have an actual setup that deals with this, we have this right triangle. I don't know this angle, but we're trying to find what that is. We have 6 for this leg and 10 for the hypotenuse. So I know that I definitely have the opposite. And I have the hypotenuse. So if I'm going for the opposite and the hypotenuse, I could probably use sine inverse of 6 over 10 and see where that gets us. And this is where you're definitely going to need a calculator. So we can clear this out. We're going to be taking sine inverse. So we'll hit second, we'll hit sine, and then we hit the fraction, which in this case is 6 over 10. Simple. This is asking us to round to, what is it? The nearest tenth. So let's call this 36.9. And again, this is helping us solve for angle x. So we would say that angle x is approximately, what was it again? 36.9 degrees. Nice chilly day. Simple. Take a moment, try the next one if you'd like. So notice we're solving for angle x. We're up here. We don't know what our opposite is, but that's okay. Because recall, we could use other trig functions to get a hold of it. So cosine inverse was our adjacent over our hypotenuse. This could help us get a hold of angle x. Simple. So let's plug those in. So if we took cosine inverse of 15 over 20, this should be equal to angle x. Pretty simple. Let's take this one more time with the calculator. So now let's hit second cosine. We're now hitting 15 over 20. Close that out. 41.4. Simple. So again, we use the inverse scenario if we have to solve for missing angles. I think that might be it. I don't think this is too tough. We'll chat more about this in class. Yeah, that's it. I hope you enjoyed the video. If you have any questions, bring them. Thanks for watching.